Okay, good morning. Welcome to
Counting number 21A.
Counting number 21A. Make sure we're on screen here. Pretty good. So we started a new chapter today. It's called More with Combinations. And we ran across this example, which we spent about half an hour on. And we did find an answer, which is good news. But we did not yet find why this was an example in a section about combinations. So the example was this. You have a grid. It's 4 wide and 3 high. And you have to walk from this bottom corner to the top corner, and you're only allowed to walk along the grid lines, so no cutting across the corner. And you're only allowed to go up and to the right, so no spinning around in a circle, no going up and back, no going out, back, down, around, back, up, over, around. So only up and to the right. So how many steps are you going to take to get to the end?
There's 7.
7.
7, you have to go 4 to the right and 3 up.
Okay. So the question was how many different paths are there? And what were some of the ideas you guys had when you were trying to solve the problem?
You could make a simpler problem.
Yeah.
Alright.
So
What was your first example of a simpler problem?
it was a 1 by 1 grid. Or was a 3 by 3 grid at first.
Yeah, your first example of a simpler problem was a 3 by 3 grid. What was the problem with that?
That wasn't simple.
Yeah, that was still a tough problem.
Yeah.
So we changed
To a 1 by 1 grid.
to a 1 by 1 grid, which was definitely a simpler problem than one that we could understand. Okay, so how did things go from there?
Well, so we noticed that there was one way to just stay here at A. Like, if you just looked at this point, there's one way to get from that point to the point.
Alright, what is that one way?
Stay there, do nothing.
Do nothing. Okay.
Then you can look at these two. There's one way to get to each of them, just moving up and to the right.
Okay.
And then at this point, this finishes off the grid. There's 2 ways, because you have to come from this point or this point, and there's 1 on each. So there's 2 ways
And this way and that way.
to get to here. And that's the 1 by 1 grid.
Alright.
And now
So next,
we can expand to a 1 by 2.
yeah, the 1 by 2 grid.
Well,
I'm going to look at this grid here. So here, there's 1 way to get to here. Then there's 3 ways,
Okay.
because you have
because you have 2 from here, 1 from here.
also you can show the ways because it's simple.
Yeah,
And
it's
like
still simple
that
enough to
way.
count there. Okay.
There and then through the middle. Now you can expand to a 2 by 2.
So this one's 1. So I made this 2 by 2. Then there's 3. Then we got 3 from this one. 3 from this one, so 6 here. I'm starting to see a pattern here.
Well, I see a little bit of Pascal's triangle.
1, 1, 1. 1, 2, 1.
And then these would
And
be
then there's, if we expanded it enough, there'd be 1, 3, 3, 1. I think
and then
the
this
one's
is
over
the
here.
6
here.
of the next row.
Then there's 1, 4, 6, 4, 1.
Where's the 1, 4, 6, 4, 1?
So it's
Those
going to
do-
be in this row.
Fill in those numbers.
So there's 1, 3, 3. 1, 3, 3, 1. 1, 4, 6, 4, and then there's no 1.
Where would that one be?
It would be up here if we expanded the grid enough.
Okay.
And
Then you can say it's 1, 5. There's no 1 at the end, so it starts with 5. 10. 10, and the 5 1 is off.
Okay, so let's pick one of those 10s. You're just filling that in because you think the pattern from Pascal's triangle continues. But why does it make sense that that's a 10?
Because you have 6 coming from this dot and 4 coming from this dot.
And what does that mean?
it means there's 10 ways.
Because the way to get to this dot, you either have to pass through this dot or this dot.
And you can't make it any, you can't go down any.
Okay, Fascinating. All right.
So
It
that's,
seems like we're almost there.
that's where there's 10, and then so and there's 1, 6. I guess this one's gonna be 15.
Okay,
You
why?
see it
10 and 5.
10 and 5.
10
But there's
and
the
5.
1, 6, 15, 20.
All right.
So this is 20 because you have 2 10s, and because of Pascal's triangle.
Okay, make that 20 a good 20. And then
Then 35.
35. So it would have been tough to count,
Yeah.
but we found 35.
35.
We even found what we think is Pascal's triangle
Yeah.
here. And we found an interesting relationship of how to go backwards. If you're here, you either came from here or there.
Yep.
Okay? All right, now let's see if we can find the choosing numbers.
Okay.
All right.